Good morning, everyone. Let us solve this question. What is this question? I'm reading out for you. A wedge of mass m2, this is the wedge, is placed at rest, no motion, on a scale as shown in the figure. This is the scale. A small block of mass m1, this block, slides down the frictionless surface, is smooth, frictionless incline of the wedge. Find the scale reading while the block slides. Block slides means M1 starts slides. M2 does not move in this question. So first of all, you should understand what is the scale reading. What does the scale reads? Any weighing scale reads the interaction or reaction force on it due to mass kept on it. Masses kept on it. So this should be very clear. This should be very clear. Now, we can take, we should take these two, mass M1 and M2, as a system. So this system will have a center of mass. So when the block M1, as per question, block M1 starts moving, it means center of mass will also move. M2 is stationary, given in the question. So first thing what we should try to extract out of this information, the acceleration of M1 and M2 system, this system. Okay. So acceleration of M1 and M2 system. Now, you know that M1 is experiencing a force in the vertical direction due to gravity. So due to which it will be having an acceleration. Acceleration g in this direction. So what will be the component of acceleration along the incline of the wedges? This angle is given this angle as per question is given theta. Sorry. So this will be your 90 minus theta, 90 degree minus theta. So it means if G is here, so in this direction it will be G sine theta. So with this G sine theta, your M1 will start coming down. This surface is smooth, no friction. So only force along the incline will be due to the gravity force, that is mg sine theta, and g sine theta will be the acceleration of m1 along the inclined plane. M2 is stationary. So let us write the acceleration of its center of mass. Center of mass of the system M1 and M2. Because we have taken M1 plus M2 as a system. So what is the way of writing the acceleration of your center of mass? We will represent the acceleration of center of mass with ACOM. So you know about this. Which all components are there in the system M1? M1 is one component. What is the acceleration of that? G sine theta plus second component of this system is M2. What is the acceleration of that? 0. What is the total mass of the system? M1 plus M2. So this equation you know. So from here you will be getting ACOM as M1 G sine theta divided by M1 plus M2. So this will be the acceleration of center of mass of the system M1 and M2 in this direction, because we have written the equation for this direction. So what will be the component of acceleration of center of mass of M1 and M2 system in the vertical direction? This is 90 minus theta. So we can write A con sine theta. So for the system M1 and M2, if we represent center of mass as a point, the forces acting on it in the downward direction is, one force is gravity force, M1 plus M2 into G. Other force will be the reaction force. That is normal reaction force from the scale on the system of M1 plus M2. So this you very well understand. I'm assuming this. If not, let me explain. How is your weight? Your weight is like this. Your block is draw it again. Sorry for the delay. This is a wedge. This is a block. M1, M2. Contact force N will be coming on it from the scale. Equal and opposite force will work on the scale N. And we are interested in knowing this N, this normal reaction force. This will be the scale reading. So what we have done here, we have taken the center of mass of M1 and M2 as a point and showing that, okay, M2 is getting pulled by the gravitational force M2G. M1 is getting pulled by the gravitational force in the downward direction M1G. So this is your M1 plus M2 into G. So this I am writing for the center of mass. And N is the reaction force on this system. So this is your N. And we know that acceleration of center of mass in this direction if we say this direction as y direction, let's say this is y direction, so it will be easier for us to write a comma y. So we can write the equation for the system M1 and M2 as M1 plus M2 into G, the downward force, minus N, because it is acting opposite to this M1 and M2G, so minus N will be the total mass of the system into acceleration in the y direction. This we are interested in finding out. Acceleration of center of mass in the y direction we have already shown here. So we can comfortably write the m1 plus m2 into a comp sine theta. Your left side is m1 plus m2 into g minus n. So your n will be equal to m1 plus m2 into g minus m1 plus m2 into ACOM sine theta. Now put this value of ACOM from this equation m1g sine theta divided by m1 plus m2. So you can go further writing this as m1g sine theta divided by m1 plus m2. These two cancelled out. Minus 1 sine theta over here. So you got m1 plus m2 into g minus m1g sine square theta. So m1g we will take common. We get 1 minus sine square theta plus m2 into g. So this has become cos square theta. So g we will take out. So this will be m1 cos square theta plus m2 into g. So finally you got n as m1 cos square theta plus m2 into g. Go back to the question and check the option, which one is matching. So you can see that this one is matching. So our answer will be option D. So you can write your answer is option D. Hope you understand it fully. In case any difficulty in understanding, you are welcome to write in the comment box. I will explain your doubt, but try to be very specific which point and where you feel the difficulty has come up. Thank you.